0. So this is also a linear equation, okay, because there is two variable, so we should have equation number 2 only. Okay, equations are called pair of linear. If I draw this line through these 3 points, which is the intersection point of two lines. Okay, this is the geometrical representation of geometrical solution, you can say, of these two linear equation of. In the third case, there is two equation and their graphical representation is parallel. Okay, they never intersecting. This is coincident and this is parallel lines representing intersecting lines. And what is the algebraic interpretation? Exactly one solution. And what is the nature of the solution? What is called inconsistent solution and what not equal to C1 by C2? In this case, we are not getting any solution. This is inconsistent. Hello everyone, welcome back to my channel. So in this session, we will discuss chapter number 4, which is pair of linear equation of two variables. What is linear equation? Let us understand this word. So in the previous classes, we know about what is linear equation, what is quadratic equation, what is cubic equation. Okay, and this is decided by the degree of the polynomial. Okay, if the degree of the polynomial is 1, then you can say this is linear polynomial. Okay, if the degree of the polynomial is 2, it is quadratic polynomial. If the degree is 3, it is cubic polynomial. Okay, so if I write ax plus b equals to 0, here variable is x, one variable, and the highest power of the variable is 1. So this is a linear variable. And how can we find out the value of the x? We find out the value of the x. Ax equals to minus b and x equals to minus b. And in the previous sessions, we know these as a zeros of this equation. Okay. So now we find out x equals to minus b by a, and this is the root zeros, okay, of this polynomial. Okay. Basically, there was one variable, that's why we found out the unknown variable, value of unknown variable minus b by a. If we write here ax plus by plus c equals to 0. So this is also a linear equation, okay, because the power of x and power of y is 1. Okay, there is two variable and power is 1, that's why this is a linear equation, but it is two variable, linear equation of two variable. Okay, so this is there is unknown variable x and y, so we can find out the value of x and value of y, but by one equation we cannot find out value of x and value of y. If there is two variable, so we should have equation number 2 only. Okay, so we have to write another. Suppose this is a1x and b1y and this is c1, and this will a2x plus b2y plus c2 equals to 0. So if there is two variable, we need two equation to find out the value of x and y. And these linear equations are called pair of linear equation of two variables. Let us take up example of a pair of linear equation of two variables and discuss their geometrical representation. Okay. So in the previous class, that is class 9, we know how to locate a straight line in a graph. Okay. To locate this straight line in a graph, we have to find out the solution of x and y. Okay. So let us find out the solution of x and y. So x minus 2y, we can write it x equals to 2y. If I put the value of y is 0, we get 2 zeros are 0, that means x is also 0. If we put the value of y is 1, we get the value of x is 2 1 ja 2. If I put value of y is minus 1, we get 2 into minus 1, that is minus 2. So for this equation, we got this table. Okay. Now we are going to find out second table for this equation. So from here we can write 3x equals to 20 minus 4y and x equals to 20 minus 4y by 3. So x and y. So x into y. If I put the value of y is 1, we got 4 on the 4 and 20 minus 4 is 16. But 16 is not divisible by 3. If I put minus 1, if I put minus 1, we got plus minus 4 into minus 1 plus 4 and 20 plus 4, 24, 24 by 3, 8. So if I put y equals to minus 1, we got 3, 8 get 24, that is 8. Okay. Now if I put 2, 2 4 the 8 and 12 minus 8 is 12. So 3 and 12 is divisible by 3, that is 4. So if I put 2, y ka value 2, so we got the value of x is 4. And if I put the value of y is minus 2, we get minus 4 into minus 2, 8. Minus 4 into minus 2, 8. And 20 plus 8, 28. But 20 is not divisible by 3. So we will put 3. 3 for the 12 and 12 minus 20 minus 12 is 8. But 8 is not divisible by 3. So minus 3 we will put. So 20 plus minus 4 into minus 3, that is 12. So we got 32. But 32 is not divisible by 3. So now we are going to put 4. 4, if we put 4 for the 16, 20 minus 16 is 4, 4 by 3 is not a whole number. Now 20 into minus 4, 20 into minus 4, that is 16. So we got 36, 36 divided by 3 is 12. Okay, so when we put minus 4 the place of y, we got the value of x is what? 12. Okay, so this is going to we put on the graph. Okay, so let us draw a graph. This is x-axis, x dash, and this is x, and this is negative side, positive side of y-axis. This is negative side of y-axis. So now we have to point out. So in the x-axis, maximum point is 12. So we have to mark it up to 12. This is 0, 0, 0, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. And in the x-axis, y-axis, we need y 0, 1, at least 1. 0, 1, 2, 3. And in the y dash, we need minus 1, minus 2, minus 2, minus 3, and minus 4. And here, this is minus 1, minus 2, minus 3, minus 4, and minus 5. Okay, so first 0, 0. So this is the point 0, 0, and 2, 1. So 2, 1. So this is the point at minus 2, 1. So minus 2, minus 1. So this is the point. Okay, so if I draw the straight line, we get like this. So this is the point. So this is the straight line for 1. Next 8, minus 1. So this is x-axis 8 and 1. So this is our point. This should be our point. Next 4, 2. So 4, plus 2. So plus 2 means this side. Okay, this side will go. Right. 12, minus 4, that is 12, and minus 4, that means here. Okay, so we'll got 12. So if I draw this line through these 3 points, we get a line approximately this point. So this is the intersection point of two lines. Okay, so what is the point basically? 4, 2. So 4, 2 is the 4, 2, 4, little bit 2. So 4, 2 is a intersection point of these two lines, and this is the geometrical representation of geometrical solution, you can say, of these two linear equation of two variables. Let us understand the graphical representation and algebraic interpretation of linear equation of two variables. Okay, by comparing their coefficient. Okay, so here two pair of linear equation, a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 equal to 0. So coefficient of x is here a1 and coefficient of y is here b1 in the equation number 1, and in the equation number 2 where coefficient of x is a2 and coefficient of y is b2. Okay, so comparing their coefficient means coefficient of x and coefficient of y and constant term, we going to decide their graphical representation and algebraic interpretation. Graphical representation can be three types. Number one, if I draw a graph, so in the previous sums we represent two linear equation on the graph and the solution will come like that. So we got a intersection point. So this can be one solution of pair of linear equation, and then next this can be a pair of linear equation. One line is this is and another line this is overlapping. Okay, so these basically these have many solutions. Okay, and in the third case there is two equation and their graphical representation is parallel. Okay, they never meet each other, parallel line. Okay, so this is intersecting, this is coincident, and this is parallel lines. Okay, how when they are showing like this solution. So let us discuss without locate any point on the graph by by comparing their coefficient. So when a1 by a2, what is a1? A1 is coefficient of x. In this a1 is coefficient of x first in the first equation and a2 is coefficient of x in the second equation. a1 by e2 not equal to b1 by b2. Then we can say these two lines representing intersecting lines, and what is the algebraic interpretation? Exactly one solution. And what is the nature of the solution? Exactly one solution. And you can say this is unique solution. Okay, unique solution. When a1 by a2 equals to b1 by b2 and equals to c1 by c2, then these two pair of straight lines represent coincident lines. Okay, then an algebraic representation is infinitely many solution. When a1 by a2 equals to b1 by b2 not equal to c1 by c2, a1 by a2 equal to b1 by b2 but not equal to c1 by c2, these pair of linear equation representing parallel lines. And algebraic equation representation is no solution. These two equations have no solution because they are never meet each other. So how can they provide any solution? Well, let us understand this theory by taking example. So first example. So first we are going to compare a1 by a2. Here a1 is 5 and a2 is 7. So 5 by 7. Here b1 is -4 and b2 is 6. Okay. Here a1 c1 is 8 and c2 is -9. So see here 5 by 7 -4 by 3, we can cancel that. 2 to the 4, 2 3 the 6, which means 2 by 3 and 8 by 9. So they are unequal. a1 by a2 not equal to b1 by b2 and this is also not equal. So this kind of representation we saw in this case number 1. so that this pair of straight line representing intersecting lines. And what kind of algebraic interpretation? This is exactly one solution. It gives exactly one solution. In the second case, if I see A1 is 9 and A2 is 18 and B1 is 3, B2 is 6 and C1 is 12 and C2 is 24. So 12 by 24. So in this case, if I cancel 9 1 the 9, 9 2 the 18, 3 1 the 3, 3 2 the 6, 12 1 the 12, 12 2 the 24. Means 1 by 2, 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 1 by 2. They are equal to each other. Means this case we are say that we can see this is represent coincident line. This pair of straight line represent coincident line, and this pair of straight line has infinitely many solutions. In the third case, if I say A1 is 6 and A2 is 2, so we can write 6 by 2, and here B1 is minus 3 and B2 is minus 1. Minus 3 by minus 1. And in this case, C1 is 10 and C2 is 9. So 10 by 9. Okay. So 2 3 is 6 and this is minus minus plus. So it becomes 3, 3 and 10 by 9 is 10 by 9. So we can see A1 by A2 equals to B1 by B2. So this is case and C1 by C2 is not equal to. So this case is matching. So that's why this pair of straight line represents pair of lines, and this pair of straight line has no solution. It has no solution. Okay. So in this way we can easily find out what kind of solution they are giving and what kind of graphical representation they are showing. Let us discuss what is called inconsistent solution and what is called consistent solution. So when the pair of solution has a solution, unique solution, then we can say consistent solution. And when the pair of linear equation of two variables has no solution, then we can say this is inconsistent solution. Okay. So consistent solution we will get in this case A1 by A2 not equal to B1 by B2, or you can say A1 by A2 equals to A2 B1 by B2 equal to C1 by C2. Okay. And this case also we get many solution, and so we are getting solution but many solution. So it can be also consistent solution. But in this case A1 by A2 equal to B1 by B2 but not equal to C1 by C2. In this case we are not getting any solution, means no solution. That's why in this condition we can say this is inconsistent solution. Okay. So in this video basically we covered all the conceptual, or you can say base part of this chapter. In the next session we will discuss 3.1 according to new syllabus. Okay. Then I hope you are understanding this video very well, and please like, share and comment on the comment section. Then I can understand where is the problem or not. Okay. Thank you for today.